The video controller, monitor control card, breaks down the data received from the motherboard into digital or analog signals that can be processed by the monitor. Depending on the type, higher resolution requires analog signals due to the size of the connector and sends it to the monitor. The video controller includes a video memory that stores the coordinate points of the screen and the color of its pixels in a matrix-like manner, divided into rows and columns. The memory of each older type of video card fits in the range reserved for the base memory, so no separate memory modules are required. The card communicates directly with the main memory. Because the memory requirements of a VGA and SVGA controller are often well in excess of 128 KB in the range reserved for it, A000000BFFFFFF, it has its own memory modules and sends data to the base memory through this. There is also a special IC on the control board, graphics chip, which controls the monitor via the video memory. Synchronizes this task with the specified clock signal, type-specific speed. The video card can be accessed through its driver. There are several types of cards. The original IBM PC video card, MDA, monochrome display adapter, can only display monochrome and text. Memory size is 4 KB. It has a maximum resolution of 80 characters horizontally and 25 characters vertically. A character consists of 9 × 14 pixels. The card emits digital signals. The CGA, color graphics adapter, is a control card from IBM. It can be used for both color and graphic display. Memory size is 16 KB. In text mode, the resolution is 80 × 25 characters and each character is 8 × 8 pixels. In graphic mode, it has two resolutions, 640 × 480, 640 horizontally, 480 vertically, black and white, and 320 × 200, 4 colors. There are digital signals on the card connector. With a small conversion, we can use it instead of a TV. The Hercules video card can only display in monochrome, but its resolution is 720 × 48 in graphics mode, 80 × 25 in text mode, and one character is 90 IMES 4 pixels. The size of the video memory is 64 kilobytes. The signals at its terminals are digital. Because it is not supported by the IBM BIOS, not manufactured by IBM, it is necessary to load an additional program that supports Hercules mode. The AGA, Advanced Graphics Adapter, control card is designed for Commodore PCs. Compatible with CGA and Hercules cards, but also capable of 132 × 25 and 132 × 44 character resolution in Hercules text mode. Transmits digital signals to the monitor. The IBM MEGA, multicolor graphic adapter, card is analog controlled and includes a digital to analog converter. It has a maximum resolution of 320 × 200 pixels in 256 colors in graphic mode, 80 × 25 characters in text mode, and a character of 8 × 16 pixels. The AGA, Enhanced Graphics Adapter, is an enhancement to CGA. This was also manufactured by IBM. It has a maximum resolution of 640 × 350 pixels and can display 16 colors from its 64-color palette at a time. In text mode, the maximum number of lines is 43 characters, the resolution of the characters is 8 × 14 pixels. It can emulate CGA and MDA video cards. Its memory size is up to 256 KB, which it uses divided into 4 64 KB areas. Uses digital signals. Some control cards have expansion ROMs and their own special BIOS. The IBM PGA, Professional Graphics Adapter, is the first analog-to-analog monitor control card with a digital-to-analog converter. It has a resolution of 640/480 pixels and can display 256 colors from a 4096 color palette. It has its own processor. GA, Video Graphics Array, is an enhanced version of AGA. Its first copies were made by IBM, but are now manufactured by many companies. The standard GA card is 256 KB. A card with more memory is called an SVGA, Super VGA, card. A 256 KB VGA card has a maximum resolution of 640 × 480 pixels. The number of colors that can be displayed is 16. This is the standard VGA mode, with a resolution of 1 MBEG 1024 × 768 pixels, color depth 8 bits. It has an expansion ROM and its own special BIOS. It also includes a digital to analog converter that converts binary data in video memory to analog RGB signals for a VGA monitor working with analog signals. Because the 128 KB of reserved memory in the base memory is not enough to store an image larger than 128 KB, it includes its own memory modules that can be expanded depending on the type of card. Because SVGA cards were not standardized, the VESA consortium standardized SVGA resolutions and color depths. The most commonly used resolutions are 640 x 480, 800 x 600, 1024 x 768, 1600 x 1200 and 1920 x 1440 pixels. The ratio of horizontal to vertical resolution is usually 4:3. The most common color depths are 4-bit, 16 colors, 8-bit, 256 colors, 15-bit, 32,768 colors, 16-bit, 60,536 colors, high color, and 24-bit, 16,777,316 colors, true color. The latest cards also reach 32-bit color depth. Such a card also stores color information in 24 bits. The human eye can only distinguish 24 bits of color. The remaining 8 bits are used by the alpha channel for various properties, e.g. transparency. High-speed 2D and 3D accelerator cards are becoming more common. Previously, separate cards that could be inserted next to a video card were produced, but more recently, the video card itself has been further developed. Such a card includes a high-clock graphics processor that takes over some of the CPU's work with various drawing instructions. This, in turn, requires cooling. The latest and fastest video cards have not only a heatsink, but also a heatsink. 3D cards store data from three-dimensional images in 3 buffers, memory areas, instead of 1. It stores the coordinate points of the first 2 dimensions of the image in the front buffer, the coordinate points of the next image in the back buffer, and the coordinate points of the third dimension in the Z buffer. Thus, although more memory is required, the graphics processor does not have to process a lot of data at once, in 3 steps. You can calculate the memory requirements for an image with a specific resolution and color depth. For 2D images, resolution, in pixels, times color depth, in bits, 8, e.g. 800 x 600 pixels times 32-bit 8 equals 1.8 MB. For 3D images, resolution, in pixels, times color depth, in bits, times 3/8, e.g. 800 x 600 pixels times 32 bits times 3/8 equals 5.5 MB. 1920 x 1440 pixels times 32 bits times 3/8 equals 32 MB. For 3-dimensional representation, 2 standard control programs are mainly used. One is DIRECT3D, part of DirectX, developed by Microsoft, and the other is OpenGL, a product of Silicon Graphics. There are video cards that have a TV out and input jack. Such cards can be connected to a TV and watched on a computer, and a movie running on it can be recorded on the computer. With video cards with a TV tuner and separate TV tuner cards connected to the antenna, satellite receiver or cable network, you can capture and tune TV broadcasts in a system, PAL, SECAM, NTSC, and frequency range, approx. 70 to 108 MHz, that matches the TV tuner. Its image quality is determined by its resolution, color depth, and speed. Speed is the number of frame per second, FPS. The higher the quality of the frames and the faster they appear, the more memory they require. To this must be added the quality of the recorded sound, i.e. the bandwidth, frequency range, the resolution, how many bits of depth the sound is stored, and the effect of mono or stereo. The VHS video recording quality approximately is equivalent: 388 x 284 resolution, 15-bit color depth, 25 FPS, usually 22 kHz, with 16-bit audio. Some TV tuner cards also include a radio tuner, which allows you to receive radio broadcasts by connecting a separate radio antenna. The video controller operation. The digital data walk from bus system to graphical chip, then to video memory, then to digital analog converter, and finally the RGB signal appears on the monitor. Storage of pixels in the video memory. The contents of the video memory are displayed on the screen.